factor out a greatest common factor first. Remember, factoring is just the opposite of multiplying, and when we pull out something, we're using the reverse of the distributive property. So I want to look at the number parts and see what's in common, and I can see I could pull out a 17, or I could pull out a negative 17. And the choice is going to be up to me, and it's going to depend usually on the next step when I'm doing a factoring problem that's longer than this one. This one's just a greatest common factor. So I can see I can pull out a 17 from both. I look then at my variables, and I see I have an x in both of my terms, and the lowest exponent is a 3, so I'll use that x to the third. That's in common between the two terms. And then for the y, I see I have a y squared on both, so I'll put a y squared there. Then I'm going to put parentheses and put what I need to multiply this greatest common factor by to get this first term here. And since my variables match exactly, my 17's the same, all that I need is that negative, so I'll make it a negative 1. And then I want to add in whatever I have to multiply by this greatest common factor in order to get this term. And I know 17 times 2 is going to give me the 34, so I need a 2 in there. X cubed, I need to multiply by just a plain old x to get that second variable, or this first variable, the x. And then the y squared is the same on both, so I don't need to have a y in there at all. So it's negative 1 plus 2x inside the parentheses. Now with the negative 17, I'll still want to pull out an x cubed and a y squared. But now this time my sign's going to change because this matches, my greatest common factor matches exactly with my first term in the original polynomial. So I really only need to multiply it by a positive 1. And then instead of a positive 2x, I will need to make it a negative 2x, so that when I multiply negative 17 times negative 2x, I get negative times negative will give me a positive, and 17 times 2, of course, is that 34. X cubed times x will give me x to the fourth, and y squared times no y will just give me y squared. Now either of these answers is correct, like that or like that, and like I said before, it just depends on what's more convenient for you. I do want to point out, however, this 1 and the negative 1 on the first part are very important. And the reason they're very important is because it's a placeholder for this first term. And if I'm using the distributive property to check, I want to take this whole greatest common factor and multiply it by the 1. If there's not a 1 there, then I'm only going to end up with this second term. So this 1 is very important. And to check, I will, of course, just multiply out. I did some of that for you verbally, but I'll show you one way I can check it out on paper. So I want to distribute my greatest common factor to the first term and to the second term. When I multiply these two, it's negative times positive, so I get negative 17x cubed y squared. And then for my second term, I have negative times negative, so it'll be a positive 34. My x cubed times x will give me x to the fourth, and the y squared has no matching y to multiply by. This should match exactly with what I started, and it does, so I know that what I pulled out and what I left inside the parentheses when multiplied together is equivalent to what I started with. Now, the next problem is partially factored, and I want you to see that this x minus 5 is the same on both terms. The 2 and the 3a are not the same, so my greatest common factor actually can be a quantity of x minus 5, and if I pull that out, if I divide each of these by that x minus 5, what I have left is just this 2 here. Let's see, that came right to there, and the 3a. And that came right to there. So I was partially factored, and I had an x minus 5 that was in common. I pulled it out to the front, and what's left is the 2 plus 3a. Now if I want to double check that this is my answer, because I believe that is my answer, I have to do a little bit of a sneaky check and take this whole x minus 5 and distribute it by each term. And when I do that, I have 2 times the quantity x minus 5 and then plus 3a times the quantity x minus 5 again. And that is what I started with over here, so my answer checks here also. Here's some problems for you to try out. And I'll assume you're ready for the answers now. I want to look at the number parts, and I could pull out a 4 from both of the numbers, and there's no x's on the first term, but there is one on the second term. I do have y's on both terms, so I can pull out a y, and I look for the smallest exponent. I have a 2 and a 3, so I choose the 2. And then there's no z on both terms, so I can't pull that out. So 4y squared, and what will I multiply 4y squared by to get 4y squared z? Well, there's just a z missing, so I'll put that in the parentheses. And then I have a minus, and 4 times what will give me 16, and that'll be a 4. And then I have no x in my greatest common factor, so I will need an x inside the parentheses here. And then y squared times what is y cubed, and it's just a plain old y. So there's my result. My greatest common factor is 4y squared, and what's left is z minus 4xy. Now to check that, I just multiply out again. And I'll take this whole greatest common factor and distribute it back inside the parentheses. 4y squared times z will just be 4y squared z, and 4y squared times negative 4xy will give me negative 16x and then y cubed. And if I look back, that's just what I started with, so it's a good check. The last problem of the greatest common factors, I have this 5a plus 2 that's in common on both of them. I want to pull that out to the front. And when I pull this out to the front, like that, I have left this 2a, and I have this negative 4. So I have 5a plus 2 times the quantity 2a minus 4. Now to check that again, write it over here. Take that whole greatest common factor and distribute it instead of using FOIL, which is what we would normally do. And then it will be 2a times the quantity 5a plus 2 and negative 4 times the quantity 5a plus 2. And that one does check because that matches exactly with what I had before. Alright, let's move on to another method. This is factor by grouping. We've already done just a little bit of it. But the first thing that I want to look at on a problem like this is, do I have a greatest common factor before I start factor by grouping? And I look at each term, I can see that there's a 3 that I could pull out from each. I'm looking at the a's. There's not an a on this last term, so a can't be in my greatest common factor. I look at my b's, and there is a plain old b on every term. And then I look at my c's. There's no c here, so I can't use c as my greatest common factor. So 3b is my greatest common factor, and if I divide it on each term, I would end up with a 3ac squared, and for this term I'll have a plus 2a squared c, and on the next term it'll be a 2a, and the last term will be a plus 3c. Now looking at the part in the parentheses, I'm just going to keep this 3b down for my answer, but looking at the part in parentheses, I see I have 1, 2, 3, 4 terms, and they're separated by addition, so you can look at it that way. There's a term, a term, a term, and a term. So if I have these 4 terms, I want to look at the first 2 as a pair and look for a greatest common factor, and then look at the last 2 as a pair and still looking for a greatest common factor.